Hello, my name is Steve Browning, Managing Director of BioNeutral Laboratories. We're here today in the heart of Manhattan, where at any moment, terror could strike much the same as it did at 9/11, but different type of terror. We're talking about bioterrorism. And bioterrorism takes many different forms. Today, we're here at our Midtown offices to talk with our Chief Scientist, Dr. Andy Kilbania, and our Chief Scientific Advisor, Dr. Philip Tierno of Langone Medical Center, to discuss some of the microorganisms that are potentially lethal and lurk in the hospitals throughout the world. So why don't we go inside and meet with Dr. Tierno and Dr. Kilbania and hear what they have to say about our new formula, the Y gene.
Hello, I'm Dr. Andy Kilbania, Chief Scientist at BioNeutral Laboratories. BioNeutral is a specialty chemical company focused upon eliminating toxic materials from the environment which are threats to individuals. We have two product lines. We have O gene, which eliminates toxic gases and odors, and Y gene, which is an antimicrobial and eliminates harmful microorganisms. The technology platform which underpins our Y gene platform of products is very robust, and we can easily customize Y gene to go after specific in-use applications. For example, we have products in the Y gene family which range from sanitizers to consumer hard surface disinfectants to sterilants to industrial grade materials and homeland security and military grade materials. Today we're going to focus on our hospital grade type of Y gene antimicrobials, and to help us with that discussion, we're very fortunate to have Dr. Philip Tierno, Chief Microbiologist at NYU Langone Medical Center. Dr. Tierno, thank you very much for being here today.
Oh, thank you.
Very good. Dr. Tierno, could you tell us a little bit about your background and area of expertise?
Sure. I've been a clinical microbiologist for about 40 years. I'm currently Director of Clinical Microbiology and Immunology at New York University Medical Center, now the Langone Medical Center. And I have published extensively. I'm a member of many medical and scientific societies, and my expertise is in the area of medical microbiology.
Thank you very much. Today we'd like to focus upon the use of Y gene in the healthcare sector. Okay. Today in the press, a lot of activity and things being published about superbugs, bugs that are resistant to antibiotics such as MRSA, Klebsiella pneumoniae, Pseudomonas. Can you tell us what the implications are of these microorganisms in a healthcare setting? What risk does that bring to an individual?
Well, one of the biggest problems hospitals have is from nosocomial infection. Those are hospital-acquired infections, and usually very antibiotic-resistant organisms, such as the MRSA you mentioned, as well as ESBLs. These are extended spectrum beta-lactamase producing gram-negative bacteria. In addition, VREs, vancomycin-resistant enterococci, are prevalent. And we now have some Klebsiella pneumoniae that are carbapenemase producers that are pan-resistant to all known antibiotics. On top of all of that, we have numerous agents that are potentially very toxic, and they're found in hospitals such as Clostridium difficile. And as the name implies, these spore-forming organisms are very difficult to kill. These are the types of bugs that we deal with on a daily basis at major medical institutions. In fact, nosocomial infections in general in America are so bad that we get about 2.5 million cases annually, which result in about 100,000 deaths, 70,000 as collateral deaths with other underlying situations at play, and 30,000 overtly from these organisms directly as a cause of death. That's at a cost of near $5 billion annually.
Wow.
That's the cost involved.
In terms of your, I guess, study and familiarity with our Y-gene type of antimicrobials, how effective are our Y-genes against these types of microorganisms?
I have personally tested the Y-gene permutations against all of the organisms I mentioned, and a few others that we didn't mention that you usually don't find in a hospital, such as Bacillus anthracis, the vaccine strain. And there is no product that I have tested that results in a quicker kill, that results in a broader spectrum, meaning it covers the range of different organisms, fungi, bacteria, anaerobic spore formers, aerobic spore formers, and viruses, nor any product that will give a residue that is green, so to speak, any more than this product. In fact, it has been found to be efficacious across the whole spectrum of organisms I mentioned. And the good thing is, I got 100% kill of all of these organisms, regardless of how antibiotic resistant they were.
Very good. Can you you made a comment about a material being green. Can you make a comment about what's being currently used in terms of eradicating these microorganisms and the harshness they are, or pose in terms of individuals using them, and the hard surfaces that are being treated versus the Y-gene type of antimicrobial?
It actually depends on the area of use. Some institutions employ aldehydes, like glutaraldehyde. They employ hypochlorites, which are very, very volatile and caustic. They employ a wide variety of relatively dangerous chemicals to effectively kill these organisms in a hospital environment. They also use organisms like quaternary ammonium compounds that have a longer time to kill. And these do leave a residual effect in the environment. And over time, that residual effect has to be cleaned up to some degree.
Okay. We talked a little bit about the resistant type of microorganisms, but some microorganisms also develop a resistance to antimicrobials. Do you envision microorganisms developing a resistance to Y-gene?
I do not believe that they can, based on the formulation, in that you have a multiple way that the material kills organisms. Even development of mutation is not a likelihood. For example, it's generally said you have 1 in a million chance of mutating. If you have 2 antimicrobial agents used, you have 1 times 10 to the 12th. That's 1 with 12 zeros after it. Well, this Y-gene formulation kills in at least 4 or 5 ways. In order to develop a resistance, you'd have to really circumvent 5 processes, which is improbable.
Okay. Well, thank you very much, Dr. Tierno, for your expert comments and insights into Y-gene and how they operate in a healthcare environment. We wish to thank Dr. Tierno for his expert insight, comments, and expertise in terms of discussions of our Y-gene antimicrobials for hospital-type applications. We at BioNeutral are very excited about our Y-gene product line. It is underpinned by leading technology which sets a new standard for antimicrobials. In terms of any antimicrobial on the market today, we believe our Y-gene antimicrobial has a total performance benefit package which far outdistances the competition.